Hi, my name's Jim, and I'm programming a baseball game. I'm programming a fairly simple baseball game for my video game physics class, which I'm teaching basically mechanical simulations, right? I'm teaching students how to make physics-based games using the Python programming language. And so you see the Python stuff right here. And if I'm lucky, you've already watched the first two videos. Those videos are PowerPoint presentations, but they're very important. The first one was a design document, told you what sort of things I needed to program and how I was going to program them sort of in a flow chart. You should do that sort of stuff before you start your game. Have a plan, have a game plan. No plan survives first contact with the enemy, but it's good to have a plan so that you can modify it along the way rather than just, bopping around with no real goals. On top of that, I did the second thing, which was planning out some of the things that I'm going to have to draw. Now, I didn't have to do the second part of that thing. I did two things in the drawing. I did one, the field, which is what I'm going to program today. The second part was one of the figures that I'm going to have to draw for animating the pitcher. And I'm going to animate both the pitcher and the batter. I only wanted to do one of those things because I really just want to do an example. I don't want to go through and do 10 of those examples and explain each one of those dots and things like that along the way. That's not going to be very helpful for you. So, here I am. I'm going to take this slide, which, there's a larger one on the actual video, and I'm going to take that and I'm going to put it into the computer. Right, because I've got two slides with PowerPoints, and it's time to start programming. Right, I mean, you want to start programming at some point. You have to start programming. So let's start programming. And the first thing you need when you start programming something is you need a title. Why do you need a title? Because it's right there at the top of the boilerplate that I give you, and I have a boilerplate video to get you familiar with this if you're taking the class. It's just really important to have a title, right? Have something that you can say, I'm doing this. Otherwise, you're just saying, I'm doing my baseball game. You could do that. You could name it baseball. And then you have to have an author. And the author is going to be you, right? And you are Jim Ranchler. Oh, no, that's me. Okay. Anyways, I'm Jim Ranchler, and this is my video game. So now that I've done that, I'm going to want this video game to be the best game it can be, right? Because now I'm in charge of it, right? Do that the first thing. Write your name there first thing. You're going to have a lot easier time programming if you take ownership of the document by writing your name right there. You don't have to trust me. I've looked at studies and stuff. They tell me that it's completely true. And you have to believe studies, especially studies like this one that I saw on the internet. And you're hearing it from me on YouTube on the internet, so it's got to be true. Anyway. What I'm going to do is I'm going to talk about how to use this draw field function basically and the field class, and to just get this background here. So I've already done the background work. I've gotten the dimensions that I want to put in there. I've gotten the dimensions, the positions for all of these different little elements. I've got 4 elements in there. I think a line, half of an ellipse, and 2 rectangles. I have to draw those onto the field somewhere. And the place where that happens is right here, but we're not really ready to do that right now. Because, why aren't we ready to do that? Because we haven't actually told it what the size of the field is. We have to tell the computer where the size of the field is when the field is initialized. So the size is this 2-element tuple, and the first element, which we call element 0, is the width of the field, which we said is 72.5 feet. We'll go with feet. The field size is in feet. And the height, I said it should be something like 30, right, in the video. So let's stick with 30. 30 is as good a number as any. And then on top of... And so this is what you want to change. You want to change this field size, right? The field size is the changey thing. You don't change the screen size here. That's the number of pixels in the window when it comes up, all right? And that's something that's actually modifiable. He says resizable here. I can resize the window. And that's really where all the complication is going to come in today, is that I want you to write these games so that they're resizable, so that they can be scaled, right? I want you to think about scaling all the time, when you're doing these games. All right. So now we're ready to start drawing. Where are we? There we are. I said we want to draw here. Now there are two things that we have to use of all of this stuff that I've calculated above here. There are two numbers that are important to use. The area size, which is going to be the lower right-hand corner of the playing area on the screen in pixels. And that's going to be very important. That's what we're doing here, is we're going to convert from feet to pixels. And so this is where that point is. That's what we care. That's what we care about with that thing. Now, why is that the lower right-hand corner? It's because it's the field dimensions times the scaling factor. Field dimensions times the scaling factor. We don't have to worry about the offset. The offset's taken care of in this code here, so you don't have to worry about the offset, even though you see that wandering around. I'll tell you what to do with the offset a little bit later. You also need this scaling factor. We're going to be using the scaling factor a lot. Scaling factor converts from feet to pixels. That's what this line does. It converts from feet to pixels. You multiply that by a number, and that's what happens. So that's what we're going to want to do. We're going to want to draw something on this field. So right now, if I run this program, you just get a blank screen. We don't want a blank screen. We want some drawing. And the first thing we're going to draw is maybe the ground. This line here that goes from just before home plate to just the end of the pitcher's mound. And that's 72.5 feet. We've already said that. And that should span the entire width of the field. So hopefully that'll work. Let's see what happens. So when we're drawing something, we want to use these Pygame drawing commands, which is in one of these videos that I'm going to put up. It's also in the Pygame documents online. So I'm going to want to draw on something. What I'm going to want to draw on, I'm going to want to draw on this area. This Pygame surface object area is where I'm going to draw my field area. So I'm drawing on I've got a drawing. The first thing I answer is what I'm drawing on. Second thing is what color am I going to draw it. I'm going to draw it white in color. For a line, if you look it up, it's fairly simple. You should know offhand what you think it's going to be in this case. It's pretty simple. What sort of things do you need to draw a line? You need one point and another point, the starting point and the ending point. Well, the starting point is going to be on the far left-hand side of the screen at the very bottom, because we want the ball to go up in the air, right? So that means the left-hand coordinate is going to be 0. So the x-coordinate of the left-hand point is going to be 0. The y-coordinate is going to be the very bottom of the screen, or not the very bottom of the screen, the very bottom of the field, which is not going to be that. But that's going to be the y-coordinate of area size. So we've already calculated that, so let's just use it, right? And the y-coordinate of a variable is this bracket 1. That's how we're going to get the y-coordinate out of that tuple. Fairly simple. And what is the end point of this thing? The end point of this thing is the lower right-hand corner. The lower right-hand corner. I remember something about the lower right-hand corner. Oh yeah, that's the area size right here. This area size is the lower right-hand corner. I just have to type area size here, and I'm done. That's the point that I wanted over here. One last thing is, how wide do you want your line? If you want your line to be 1 pixel wide, you don't have to do anything. If you want it larger, you have to add in some numbers. 3 pixels wide. I think that's pretty good. I think I like that idea. So let's see what that looks like. Okay, that was supposed to go all the way across the screen. Why didn't it? Well, you know, area size goes. So according to this, everything's okay. Let's look at what I did when I defined the field. So the field is this game class object. So game class has a class field, and the field is an object based on that class. Has 3 things that go in it. We've already talked about the field size. That's right, 72.5 and 30. The field scale, I don't know what that is, but it's 0.5, and the field offset, and I don't know what that is, that's 0.0 and 0.0. Fortunately, if you go to the game class package, and you look at the field and the init method in the field, the initialization method, you see that there's some comments here in the doc screen. These tell you what these different things are. You already know what self is because self is just the name of the field. That's the thing before the equal sign. The name of the object that's going to be a field. All right. Then we have three other things: dimension, size, and offset. So dimensions is what I call field size. Size is what I call field scale. Offset is what I call field offset. Dimensions, the physical size of the plane area. We talked about that. Size, it's a number from 0 to 1 that says what percentage of the screen I'm using. I said that was 0.5, but I really want that to be 1, right? So I'm going to have to change that number. And the offset is percentage of the screen that says where to start drawing the upper left-hand corner. So I might want to change that too, because I might want to bring that screen down and center it. So I'm going to try to center that that thing first too. But first I just want to change the scale to 1.0, run the thing, see if it does what I want it to do. It does what I want it to do. Now it goes all the way across the screen. Hopefully that's really all the way across the screen, and only all the way across the screen. But that's what I've got sitting there looking at me right now. So that looks pretty good. How about the offset? What do I want to do with the offset? Well, I want to figure out how to push this this field, which has different proportions than the screen, into the center of the screen. So the 0.0 is fine because I want to use the full screen for the x coordinate, for the width, I guess. But the 0.0 for the second coordinate, the 1 coordinate, the y coordinate, that's no good. I'm going to have to change that. And I'm going to have to change that by playing with the scale here. So I want it to be half of whatever remains on the screen after I've drawn my field. So that doesn't sound good. That sounds like a lot of work, right? So it's not really a lot of work. It's just what we call in the business math. All right, so let's do a little bit of math. So the screen size is 800, and the field size is 72.5. If I do that, I can find out that there's 11.034 blah 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 pixels per foot. So I want to find the size now of the height of this plane area in pixels, right? And that would be how would I call that? I'd multiply by 30. Okay, so this plane area is 331 and change pixels. All right. Now I want to get rid of all of this stuff from the 600 here, which is the height of the screen in pixels. So plus 600. So I have 269 or so of these guys left, and I want half of that to push it down. And that's 134, but 134 isn't between 0 and 1. This I need as a proportion of the total height, which is divided by 600. So I have 23% of the screen. So let's see, does this look a little bit better if I run it? And yeah, it's gone down a little bit. So that's fine. So let me just show that this scales. So it does scale a little bit there. And that's all I have time for with this video. I'll do another one that draws the rest of the stuff and show the scales there as well. So thank you very much for watching, and I'll talk to you in just a minute.